Greenhouse gases are components of the Earth's atmosphere that have the ability to absorb and trap heat. They play a crucial role in maintaining the planet's temperature at levels suitable for life. Without these gases, the Earth would be an icy and uninhabitable place, with average temperatures far below the freezing point. The most abundant natural greenhouse gases include water vapor, carbon dioxide, methane, carbon tetrahydride, nitrous oxide, dinitrogen monoxide, and ozone, O3. Each gas has different chemical properties, atmospheric lifetimes, and warming potentials. Their combined effect forms the natural greenhouse shielding that keeps Earth warm. Among them, carbon dioxide is the most discussed due to its strong link with human activities. CO2 is released through respiration, decomposition, volcanic activity, and wildfires. However, its modern surge stems mainly from burning fossil fuels such as coal, oil, and natural gas. Deforestation also contributes by reducing the number of trees that absorb carbon dioxide from the atmosphere. Methane is another potent greenhouse gas with a global warming potential significantly higher than carbon dioxide over shorter timescales. It originates from sources such as livestock digestion, rice cultivation, landfills, wetlands, and leakage during the extraction of oil and natural gas. Although methane remains in the atmosphere for only about a decade, it traps heat far more efficiently. Nitrous oxide is emitted from agricultural soils, fertilizers, industrial processes, and biomass burning. It not only warms the atmosphere but also harms the ozone layer, making it one of the more complex gases in terms of environmental impact. Its atmospheric lifetime stretches over a century, making it a long-term contributor to climate change. In addition to natural greenhouse gases, there are synthetic ones, known as fluorinated gases. These include hydrofluorocarbons, HFCs, perfluorocarbons, PFCs, sulfur hexafluoride, and nitrogen trifluoride. They are entirely man-made and used in industries such as refrigeration, electronics manufacturing, and electrical insulation. Even in small concentrations, they have extraordinarily high global warming potentials. The way greenhouse gases warm the planet is through the greenhouse effect. When sunlight reaches Earth, some energy is absorbed by the surface and re-emitted as infrared radiation. Greenhouse gases absorb this outgoing heat and re-radiate part of it back toward the surface. This natural process acts like an insulating blanket around the planet. While the greenhouse effect is essential for life, human activities have intensified it dramatically. Since the Industrial Revolution, the atmospheric concentrations of all major greenhouse gases have risen steeply. CO2 has increased by more than 50%, methane has more than doubled, and nitrous oxide levels have surged as well. These increases have disrupted Earth's energy balance. As a result, global temperatures have risen, accelerating climate change. The enhanced greenhouse effect leads to melting ice caps, rising sea levels, disrupted weather patterns, prolonged droughts, stronger storms, and widespread ecological stress. The impacts reach across ecosystems, economies, and human health. To address these challenges, the international community has committed to reducing greenhouse gas emissions. Agreements such as the Paris Agreement push countries to adopt renewable energy, phase out fossil fuels, protect forests, and promote sustainable practices. Limiting the concentration of greenhouse gases is critical to preventing dangerous levels of global warming. Ultimately, understanding greenhouse gases is essential because they lie at the core of the climate crisis. Their rising levels are altering the planet's climate system in ways that will shape environmental conditions for generations. Managing and reducing these emissions is one of the most urgent tasks facing humanity today. Climate change refers to long-term alterations in the Earth's climate system, including changes in temperature, precipitation, wind patterns, and the frequency of extreme weather events. Unlike daily weather variations or seasonal shifts, climate change occurs over decades, centuries, or even longer time periods. It represents a persistent shift in the overall balance of the global climate. The Earth's climate is shaped by complex interactions between the atmosphere, oceans, land surfaces, ice sheets, and living organisms. These components form an interconnected system that determines global temperature and weather patterns. When one part of this system changes, it influences the others, often in unpredictable ways. Although climate has always changed throughout Earth's history due to natural factors such as volcanic activity, solar cycles, and ocean circulation, the rapid warming observed since the Industrial Revolution is fundamentally different. This accelerated change is overwhelmingly driven by human activities. The principal driver of modern climate change is the sharp increase in greenhouse gases such as carbon dioxide, carbon dioxide, methane, carbon tetrahydride, and nitrous oxide, dinitrogen monoxide. These gases trap heat in the atmosphere, amplifying the natural greenhouse effect and causing the planet's average temperature to rise. This process is commonly known as global warming. Human activities, particularly the burning of coal, oil, and natural gas, are the leading source of CO2 emissions. Industrial production, transportation, and electricity generation release billions of tons of greenhouse gases into the atmosphere every year. Deforestation, which reduces the planet's capacity to absorb carbon, further accelerates the problem. Methane emissions from agriculture, livestock, landfills, and fossil fuel extraction also contribute significantly to the warming trend. Nitrous oxide from fertilizers and industrial activities adds another powerful layer to the overall greenhouse gas burden. As these concentrations increase, the Earth retains more heat than it releases. The consequences of this buildup are profound. Rising global temperatures have triggered widespread melting of glaciers and polar ice sheets, leading to sea level rise that threatens coastal cities and island nations. Warmer oceans contribute to stronger storms and more destructive hurricanes. Climate change also disrupts precipitation patterns, causing severe droughts in some regions and intense rainfall and flooding in others. These changes impact freshwater supplies, agriculture, and food security. Many areas are now experiencing heatwaves and wildfires at a frequency and intensity never recorded before. Ecosystems across the globe are under increasing stress as temperatures rise. Species are forced to migrate, adapt, or face extinction. Coral reefs are bleaching, forests are declining, and biodiversity loss is accelerating. Climate change is reshaping the natural world at an unprecedented pace. Human societies are equally vulnerable. Extreme weather events damage infrastructure, disrupt economies, and threaten public health. Vulnerable communities, especially in developing countries, bear the brunt of these impacts, even though they contribute least to global emissions. This makes climate change not only an environmental crisis but also a humanitarian and economic one. International organizations and governments have responded to this challenge through agreements such as the Paris Agreement, which seeks to limit global temperature rise to well below 2 degrees Celsius above pre-industrial levels. Mitigation strategies include reducing emissions, expanding renewable energy, protecting forests, and adopting sustainable land use practices. Ultimately, climate change represents one of the greatest challenges of the 21st century. Its causes are deeply linked to human development and energy use, yet its consequences threaten the stability of ecosystems, societies, and economies. Addressing climate change requires global cooperation, rapid innovation, and long-term commitment to a more sustainable future. Climate change initially entered scientific discussions as a long-term shift in global temperature and weather patterns. For decades, it was viewed as a slow-moving, distant environmental issue, something that might, eventually, affect future generations. Early warnings from scientists in the 20th century were often overshadowed by economic growth, industrial expansion, and the belief that the Earth's systems were too vast to be disrupted by human activities. However, as industrialization accelerated, atmospheric greenhouse gas concentrations began to rise at unprecedented rates. The burning of coal, oil, and natural gas released massive amounts of carbon dioxide, while expanding agriculture and livestock increased methane emissions. These gases trapped heat in the atmosphere, amplifying the natural greenhouse effect. The data revealed a clear pattern. Warming was no longer theoretical, it was measurable, accelerating, and global. In the latter half of the 20th century, scientific evidence grew more alarming. Ice core records, satellite observations, and global temperature measurements all pointed to the same conclusion. Human-driven climate change was rapidly altering Earth's energy balance. Yet political and economic systems were slow to respond. Climate change was still seen as an environmental concern, not a planetary emergency. By the 1990s, extreme weather events began to intensify. Heatwaves, storms, floods, and droughts increased in frequency and severity. The Earth was sending unmistakable signals, the climate system was destabilizing. Scientific institutions, including the IPCC, warned that continued emissions would lead to irreversible damage. Still, policymakers struggled to act decisively, often hindered by economic interests and international disagreements. The first major global attempts to address the problem emerged with the 1992 Rio Earth Summit, which established the UN Framework Convention on Climate Change. This was a turning point, marking official global recognition of the problem, yet the solutions proposed were modest. Climate change remained a future risk, not an immediate crisis requiring radical action. The Kyoto Protocol in 1997 attempted to impose binding emission reduction targets on developed nations, but its impact was limited. Many countries failed to meet their goals, and global emissions continued to rise. Meanwhile, climate-related disasters began affecting millions, devastating droughts in Africa, record-breaking hurricanes in the Americas, and deadly heatwaves in Europe and Asia. As the 2000s progressed, the impacts intensified dramatically. Arctic sea ice declined at shocking speed, glaciers retreated worldwide, and sea levels climbed steadily. Ecosystems began to collapse, with coral reefs bleaching and species disappearing at accelerated rates. What was once a slow environmental change had clearly transformed into an unfolding global emergency. Scientists and activists began using stronger language to reflect the severity of the situation. Terms like global warming and climate change no longer captured the urgency of melting ice sheets, mass extinctions, and destabilized weather systems. The phrase climate crisis emerged to communicate that the world was not simply warming, it was entering a state of planetary instability. The Paris Agreement in 2015 marked another major step, setting the goal of limiting warming to 1.5 degrees Celsius. But the agreement also revealed a harsh truth: even the most ambitious national pledges were insufficient. The world was on track for far more warming, threatening food security, water supplies, and human health. Climate change had officially become a crisis, one with global security implications. By the 2020s, climate impacts were no longer gradual, they were abrupt and catastrophic. Unprecedented wildfires burned across continents, megastorms devastated coastlines, and entire regions faced chronic water shortages. Climate refugees began crossing borders, and global supply chains were repeatedly disrupted. The crisis was now reshaping economies and geopolitics, not just the environment. Public pressure grew as young people, scientists, and civil society movements demanded urgent action. Governments, corporations, and international organizations were forced to confront the reality that incremental solutions were no longer enough. The climate crisis required transformative change, rapid emission cuts, renewable energy revolutions, and reimagined economic systems. Today, the phrase climate crisis captures the world's new reality, a destabilized planet pushed to its limits by decades of inaction. The journey from climate change to climate crisis is a story of scientific truth ignored, political hesitation, and environmental tipping points crossed. Yet it is also a call to action, proof that the time for hesitation is over, and that only bold, immediate global cooperation can secure a livable future.